usual, I guess I'd like to start off by just saying that if anybody feels that this class is above or below their level of expertise or not what they're thinking, by all means, feel free to leave, and I will not take offense by it. Yeah, so by all means. I know. And ask questions anywhere throughout. Don't worry about it. I've given this presentation once before, and I had to kind of scale it down because it was originally an hour and a half long. So I think we'll still get some good stuff out of it, though. So.
Why a ThinkPad? Why do you have a ThinkPad?
Company.
Okay.
I didn't have much of a choice. So, yes, this is me. I'll have this again at the end. If anyone has any questions, you're welcome to reach out to me. Be happy to do that. About me, I started off my life, my career as a Cold Fusion developer, a company in Eden Prairie called Comp5 Web Systems, and moved from being a Cold Fusion developer to being a database administrator with another company in Eden Prairie called where2live.com. And then I moved up to W3I from St. Cloud, who is the sponsor here today, so you may have heard of them before. And just recently I moved out to be a senior SQL DBA for Boston Scientific. Again, more information. All right, so let's get into the good stuff. So, what are execution plans? So, in simplest terms, what an execution plan is, it's when SQL Server takes a query, it's how SQL Server decides on what it needs to do to that query in order to get the data, get it out, and back to you. So that's, in simplest terms, what an execution plan is. There are longer definitions that are more involved, but really what you need to know is it's how the server is operating, what it's doing behind the scenes to get that data and retrieve it. So it's useful in finding bottlenecks, and finding performance problems, and finding ways in which the server is slowing down and not getting the data necessarily as fast as you want or as efficiently as you want. That's about it for slides. So, this is not a slide, this is a demo-heavy presentation. So again, any questions, feel free to let me know. All right, so this is SQL Server Management Studio. And by the way, just I'm curious, how many people here are developers? Raise your hand. Okay. That's kind of what I thought. This was kind of geared towards developers, so let's just talk a little bit about showing you how to see an execution plan before we get into what they actually look like. So there's a couple different ways that you can see it. The first screen is up here. So there's two, I want to say, kinds of execution plans. The first is called estimated, and the second is called actual. So the difference between estimated execution plans and actual is that when you run it estimated, you don't actually run the server or the query on the server. You just have it go out and look at this, look at the plan or create a plan based on the information that you're trying to retrieve. Whereas an actual, you're actually going out and getting the data, and so what you get is you get some estimates with an estimated. We think it's going to be this many rows, and with an actual, it actually collects those statistics. So it will tell you, we estimated that you would get 22 rows back, and we actually got 30. Which may indicate a problem if you're seeing a big deal of difference. Yeah?
So, but it doesn't actually change, like, the number of, like, like how it goes about selecting and the loops and stuff. That would all be the same. The only difference between the estimated and the actual are, like, the times and the rows.
There should probably not be a difference. I guess there may be if it, for some reason, as it's processing it, determines it needs to do something different. But no, I think almost always you're going to see the exact same plan. It would just be some difference in some of the numbers that are returned. So this is how you can see, one of the ways in which you can see an estimated. There's a button right here, display estimated execution plan. And then actual, there's a button right here. So if I was to highlight this, and I said, oops, I have to connect to my server. All right. So if I say, all right, estimated, it's going to come back, it's going to show me the estimated plan. It hasn't done anything. If this was an insert statement, it would not have inserted any data. If I say include actual, which is so this one you push one time, you get it one time. This one you set it, and then every time you run a plan or a statement, you'll get it. If I execute that, it's going to come back with some numbers, and then I can go over here to this new tab that's been created at the bottom called execution. So that's one way to see it. Another is you can right-click inside your query window, and you've got display estimated plan and include actual right here. Another way to see it is under the query option. You have got display estimated here and include actual. And then the last way, you can see it right here, Control M for actual and Control L for estimated. Most people just use these buttons. So there's a couple different types of plans. I talked about kinds with estimated and actual. In addition to that, there's also graphical plans, which is what we're looking at right here. This is a graphical plan, because you can kind of see it right there. There are text-based plans, and then there's XML plans. So you can get it back in either XML text or graphical. And what you'll see is that you get more information with text than you do with graphical, and you get more information with XML than you do with text. So it's harder to read and understand, depending on which one you go towards, but you get more information back. So depending on how in-depth you want to go, most people that are starting out and have not been doing this for a long time just go with graphical, and for the most part I just go with graphical unless I really need to dig into it. So that's that. We'll talk about, well, we're going to look pretty much at this graphical. If we have time, we'll show you text and XML. Let's see. All right, permissions. So as developers or as designers, whatever you are, you will have to have either sysadmin access, so if you're doing this in your local box, probably isn't a problem, or DB creator or DB owner access. Or you can ask your DBA to give you show plan, so grant show plan. So your DBA would run grant show plan, and then your name, too, and then your name. And that would give you access to see this. So if you don't have one of those access levels, you won't see the execution. Lastly, before we get into the actual working with it, reuse. So your optimizer on the server will store it until either the server has been restarted or until the dbcc free cache has been run. So that's the command that can be run, clears out the memory. So otherwise, the information that you get here, all this is stored in memory, and the server can reuse it. So sometimes the first time after a server's been restarted, things run a little bit more slowly than they'll run later on because the server has to generate all those plans. All right. Think? Yeah. All right, so let's take a look at our first query. So I've already ran it here. You can see it. First thing to talk about is tooltips. So as I hover over this, and these are sometimes a little touchy, like they'll just disappear on you. So that may happen, I may have to go back over it. But you get information. So I'm going to actually see here. It's working. One second. Sorry about this. This will be a lot easier if I'm using a mouse with a scroll wheel. Okay, good. There we go. All right, so a little bit easier to see. All right, so this was an actual plan. So you can see we have actual number of rows returned, 290. And then we have number of executions. So it took one execution to get this data, and it expected, it had an estimated number of 1. Get some data about I/O cost, how much I/O was involved in this procedure. So if you're having troublesome queries that are I/O intensive, then it'll show you that information. CPU intensive.
What execution? What is an execution?
So when you run a query, that's an execution.
Okay.
So
is the number of queries included in the batch?
Kind of. So that's what this operator cost is. It's how much of the batch was spent on this particular piece. That's 100%. However, you could be running one query and it might have some sub-select or some joins, and so it has to do additional executions to get that data within one query. Number of rows estimated. I don't know why they didn't put it up next to actual. So that's what the tooltip kind of looks like, and that's a lot of what we'll be looking at today. You can also get tooltips on these arrows. So this arrow shows that this would make more sense if we had more pieces of the puzzle here, but it shows that 290 rows came out of this particular section. So if we had a bunch of joins, you'd see a bunch of these objects here, one for each of your tables, and then you would see these arrows. You could actually look and see, okay, so out of this one table we had 1 million rows coming, and then it joined into this table which only had 290, and so now there's only 290 moving forward because of the type of join you're using. And then select. Now you can right-click on any of these items and go to Properties, and you'll get this window up over here. And this window gives you some additional information. One of the things that's kind of useful to take a look at is optimization level. This is trivial. You also can have full timeout. We'll talk a little bit more about those in in the future. But so trivial, didn't have to do anything. I really didn't have to think about this at all because it's just select star from. There's no where clause. We're not selecting specific rows. This was as easy as it gets for the server. It didn't really have to do anything. All right. You can read it from right to left or left to right. Typically, most people read this from right to left. So this will be your most base table, and you'll move up the table chain to get to the select. So you're going to start around here, and you move up to get to the select. So that's something to take a look at. So when we look at this, and this isn't a hard and fast rule, but typically you'll see that when you're working with indexes or with tables, you can have either a seek or a scan. So in this case, we have a clustered index scan. So we're working with the clustered index. And scan means it's looking over every single row in the table. And typically, when you're working with larger data sets that bad, you want to see a seek. A seek means it's using an index and it's going right to the data that it needs. Now there's a point, and I'm not sure exactly what that point is, it's like 1,000 or 2,000 rows, where anything below that, it makes sense to do a scan because it's just so small. The server can just bring it all in, process it real quickly. It doesn't need to go to extra files and stuff. So you actually don't have a performance benefit by having a seek. But for the most part, seeks are better than scans. So we'll take a look at some of those here with our next query. All right, so here's a little bit bigger query. So now we're going to select the title field in the human resources employee table, where the employee ID is 185. So we have one, because we're looking at one employee ID. By the way, this is using AdventureWorks. If anybody doesn't know what AdventureWorks is, it's the free database that Microsoft puts out now. And you can get it from CodePlex, which is Microsoft's kind of script library site. So you can go to CodePlex, look up SQL Server databases, and this is free. You can download it. A lot of the examples you'll see online come out of AdventureWorks, so I highly recommend it if you don't have it on your personal developer account to get it. All right, so let's take a look at the execution plan. So now we've gone from a scan to a clustered index seek. The reason is it's now looking for this employee ID, and there's an index that has employee ID on it. So if I zoom in again, let's see here. So right here we have PK employee ID. So this is back. I am not straight. Sorry about straight with my line. There we go. PK employee ID. So it's using the employee table, employee ID is the name of the index, to find this data. So that's good. It's using an index. There's a lot of rows. Also outputting the title, so it tells us that. Then it also shows us that it's looking for employee ID. It shows us that information. But this is good to know, especially if you're trying to figure out why a particular query isn't maybe working as well. I've oftentimes seen that the optimizer is not using the index I thought it would be using. So that's where you can take a look and see what exact index was being used.
When you executed that first query, it said clustered index scan, correct?
Yep.
Why did it say clustered index if it wasn't using the index?
It's a great question. It's actually one of the questions we usually ask DBAs during the interview process is, what's the difference between a clustered index and a non-clustered index? So the difference is a clustered index is actually physically laid out in the order in which the index is. So if the index is clustered index on title and first name, it's going to physically put the data into that table in title and first name. Probably not very efficient, but so if you were to get somebody in that had a name that was in the middle of the pack, it would have to move stuff around and put that name in the middle. So that's why it was a clustered index, because it was returning every single row in that table. And there was a clustered index set up, so it was using that clustered index as that was how it was physically laid out. That was the easiest way for it to get data. And by default, the order of the clustered index is always the default order. So if you don't specify an order by, it's going to be the order of the clustered index.
You only have one clustered index?
Yep, because it can only be physically laid out one way.
Makes sense.
That's the follow-up question I've asked many DBAs that come in to apply for a job, and I'll say, all right, so what's the definition of a clustered versus non-clustered index? And they'll answer, oh yeah, it's how it's physically laid out. And so then to see if they really understand it, I'll say, so what's the limit? How many clustered indexes can you have on a server? And quite often, people will be like, I don't remember the number. It's somewhere up there high. Microsoft changed it. No, it's only one because it's physically laid out that way. So that's a great question. Okay, so we talked about that. Let's move on to our next query. All right. So in this next query, we're going to see, so we're going to look for just the middle name where the phone number is like 11. Not a very efficient query, I'm sure. So we go over to the execution plan, and starting in SQL Server 2008 and above, we now have this nice text here that says, hey, you're missing an index. So it might not do this for every single query, but if the optimizer has seen enough, has got enough information, that it can say, this would really be helped by an index, it will tell you, there's an 84% impact on this query. We could make this a lot better if we added this. So,
is it 84% faster?
Well, that's a good question. I'm not exactly sure what it's relating to, if it's overall cost of the query. But let's take a look at it. So you right click on this word missing index or anywhere in this text. You go to missing index details. I'm going to move this down to here. So then it basically writes out the query for you with the index. And then you can put a name in. Now, usually you'd want to go out and take a look around and make sure that there's no other indexes that are maybe similar to this one, where adding one, if it wants phone, if it wanted 3 things in the index and you had one that had 2 of the 3, it might make sense just to alter an existing index. Because really you don't want to have more than 6 or 7 indexes. That's kind of the golden rule. Try to keep it to that. Yeah?
A couple questions on that.
Sure.
Index.
This index or the last page?
When the execution suggests an index to you or recommends one,
yeah.
Is it analyzing your past data as far as inserts and that kind of thing too, to analyze if it's a good idea or not?
I don't know that it analyzes the past data. It definitely looks at the execution plan that came back and tries to see if having an index in what you're searching for would make sense. So in this case,
it's just taking that your search query. It's not taking the rest of what it knows. Maybe it knows about that table.
It's taking what it knows about that table, but it's not like looking at your previous searches.
Okay.
So it's not going to say, it doesn't know if you execute this search once every 3 months versus 1,000 times a second.
Because there's like the index creator, index suggester, right, with
yep.
Management Studio that takes a look at basically like all the activity on that table.
Sure.
And I was just wondering if it uses that or if it just uses kind of whatever you're doing on the
This is part of that, but that's more in-depth than this.
Okay. And then is that an option that you have to turn on or off, or is that on by default after 2008?
You're talking about the part of the
recommended index.
On by default, I don't know that you can turn it off.
Okay, cool.
I've never wanted to, so I guess I never looked
right.
into that. So here we're making a clustered index. So we remember doing it on phone, and we were returning middle names. So it said, okay, we should do an index on phone, and then something new with, I don't remember when this came out. It's either 2008, it may have been 2005, but I think it's 8. Is this include option? So it does include. It doesn't really stick the data into the index and makes it really a lot bigger, like it would if it was part of the index. It includes it separately so that it just doesn't have as big an impact on the index. I guess that's the best way I can say it.
Like what is going on the programming side of the include? Is there like I'm not an expert on programming, but is there like a pointer or something?
It's basically something similar to that. Well, there's like a pointer that has that information, so it's part of the index without taking up as much room in the index. It doesn't grow the index as much as if you had it be part of the regular key of the index. Covered index means that every piece of your search terms are included in the index. So this would be simply because I'm only searching on phone, but that's not necessarily the case. I typically like to think of include as being the things in the select portions of the statement, and the on as being the things in the where portion. Yeah.
Does the include limit you to only select that? So if you're like, do another query on phone and then you want the first name and last name too,
it would be later, right? So this is where, as a designer, as a developer, you want to look at what your queries are, and you want to include the biggest query that you're going to be running. So it wouldn't matter if I put middle name, first name, last name inside here. It would still use this, and it would still be more efficient than even though I only need middle name. But then if you were only to put a middle name and you were to run middle name, first name, last name on a different query, then it wouldn't be as efficient. So you're better off to really look at what you're executing and pull back what you really need as part of this query. All around, yeah.
When you talk about including multiple fields in the index, doesn't the order of the fields in the index have an impact on the usefulness of the index?
Less less now. That was really an issue with 2000 and even 2005. With 2008 and above, they made a lot of optimization changes, and that's not so much the case anymore.
Okay.
All right, so I've already written this out, so I'm just going to go and run it off of the one that I already have written out. So here's my index right here. So create an index, just kind of reformatted it a little bit, but it's the exact same thing. All right, include phone, include middle name. I'm turning on data compression. That doesn't really matter. That's a new feature. It makes the index smaller, it compresses the data. Okay, so I've added my index. So if I go back and rerun this, execution plan. Not a whole lot changes, but let's do this so we can really see it. I'm gonna first off that, and then we'll just copy this guy out, and we'll take a look at it without the index, and we'll compare the two. All right, so there's the first one. So that's with the index. Let's just drop the index. Put on this first. I got kind of excited, sorry. All right, so. What we're going to do right now is I'm just going to compare these two bits of information about this. So one with and one without, and we'll see how the difference is. And hopefully then things will start making sense. All right, so start with, so this is again, this is without the index, this is with the index. Scan versus seek. So if we go over here and take a look without the index, we had an estimated I/O cost of 0.423. Think of it like a percentage. So 42%. It's not really, but just to help you get an idea, think about it that way. Over here, once we added it, our I/O cost dropped. So from 42%, it dropped down to 0.3%. So a pretty big difference there. Imagine if we had hundreds of millions of rows in this table. This table's only got, I think, I don't know, 1,000 rows. So CPU cost dropped from 2% down to, I don't even know what that is. Way down there. That didn't really change much. We went from a operator cost of 0.44 to 0.004. So as you can see, all around, this is making a dramatic difference on this particular query, and that's what we want to see. So if this query was being run 1,000 times a second, and it was having a lot bigger table, with a lot bigger numbers on it, making this change would make a dramatic impact on our I/O and our CPU on this on our server. Questions about that before we move on? Okay. Move on to 4. So, let's see here. Get a little more room. All right, so this is a much more complicated query. We've got a from employees. We're joining in contact 2 times because we want to get the manager. We're specifying where a manager exists, and we're having an exist statement. So we're saying it's also in this list. Let's take a look at our execution plan. So a little bit more going on. Each one of our tables that we hit, see we've got some objects for. We have a clustered index seek, a clustered index scan, and another clustered index seek. And then because we have some joins, these two were joined together, and then we joined in the third table through a join. There we go. So first thing I want to show you, we talked about before, the trivial optimization level. This is full. So it provided, and the reason it quit was because a good enough plan was found. So it actually had this plan in memory, because I ran this before. And it said, okay, I already know what the plan is for this. I've seen this before. I don't have to spend a lot of time thinking about it. That's good. What I wouldn't want to see, or what would be less, so good enough plan found, good. A little less good than saying full. The last one is timeout. So if that had timeout on it, that would mean the server gave up trying to figure out what the best plan for this was, and that's bad. You don't want to see that. So that's something to take a look at. So reason for early termination. Oh, and I guess I should have said this at the beginning, and I'm sorry. I have all of this up in my blog. You guys can go to my blog when you're done, and all of this data is up there with screenshots and everything. All right, so let's see here. Go to that again. Okay, so we have this one scan. It's taking 33% of our operation. Now we have a 53% cost in the seek, but let's say I want to start with the scan because I want to try to figure out how to maybe make that better. So, there was one thing I wanted to show you first, just how one change can make a big difference. So if I was to make this, instead of being manager ID, I was to make this employee ID and rerun this. Here we all have seeks now. 33, 33, 33. It's equal among all of them. It's how much time it's taking. Anyways, neither here nor there. I guess I just kind of wanted to show it here.
Because employee ID is primary key.
And because employee ID has an index on it, and I'm guessing manager doesn't, which is why it's giving us that scan. All right, so this is how I start to look at this. I kind of hover over and say, okay, what's it using? So it's using a scan. It's using do this. We can see. It's using manager. It's using the PK employee ID. So it's using the employee ID as the field it's searching on, but it's looking for a manager ID. So that immediately tells me, okay, this is kind of inefficient. It's outputting contact ID, manager ID, and title. So undo that. Do that.
How could it be searching on employee ID?
It's not, but that's the index it's using. So it has to look through that index to find it. So that's where it's inefficient. So it's not actually using employee ID. If I said that, I misspoke. It's using that index in order to locate this data. So it basically has to go through every single record. If it was a phone book, it would have to go through every page of the phone book looking for any instance, even though the phone book's alphabetized, it doesn't know that. It has to go look at every single person to see where it could find that bit of data.
And it's using that index because it's the primary key and there's no other indexes to use.
Or
it always falls back to the primary, right?
It doesn't always fall back. It could use another index if there was another index set up.
But if it can't find it, that's like the last resort one,
It
right?
tries to find the best one that it can find. So if there's an index out there that has some of the data it's looking for, it may fall back to that one instead. Yeah. Okay. So, all right. Let's see here. All right. I'm going to create an index. So in this index here, we can see we have. I'm going to just call it HRIXEZ1. It's going to include the contact ID and the manager, because up here, I see in the where clause we have manager, and up here we have contact and we have manager. So I'm going to throw those into an index. I'm going to include title, because title is being included up here in the employee table. This is just some hints. I'm not going to worry about those. All right, so now it's done. So now if we go and we take a look, oh, we still have a scan. Something's not right. This is where it gets a little tricky sometimes to figure this stuff out. But at least we know we could look at this and see if we made a difference. We didn't. We made a little difference, but not a huge difference. So what's going on here is that the where clause is manager ID, but contact ID is part of this join. So I'm going to try putting that inside the include instead of inside the actual index. So it doesn't really matter if I throw it beginning or end. Get rid of this. Get rid of this. I would be making screenshots if this was a longer presentation, showing you the difference. Gotta do my drop. Now, let's come to a C. So, in this instance, it did much better having that be part of the include because it was not part of the where.
How come a SQL server didn't recommend you do anything?
It may have been the percentage benefit that it saw was not that much, because this is, even though it's a much more complex query, it's not a huge query, and the difference between the beginning and the two were not as dramatic. I'm not exactly sure why it did. Quite often, I do not have the index hence make this index. Usually, I have to look at the query and look at what's existing on the server, and then make my own decision about what indexes I need to add. So it's a matter of looking at the data, knowing what my queries are, and trying to come up with ones that match. Yeah?
Why did you add the field to the include rather than add the field in the index? If it was a join, my inclination would have been to add it to the index rather than the include.
And that was my inclination too when I began, which is why it was up here. But I think that it's the way that this is set up. It's using it as the include because it doesn't need it as a full member of the join. It's data that can be included this way to get better performance. I'm not, that's a great question. I'm not exactly sure of what the answer is to that. Why it would not have needed, or why it didn't actually take it and just be the worst performing. Yeah.
Can we be forced to use the indexes, giving hints or something?
Yes, with hints. You could say, so if I had an index, I could say with index equals, and then type in the index name. Now the problem with that is that if your data changes, or if somebody starts using another query, or something else changes, that you're stuck using that no matter what. Whereas if you do it this way, the optimizer can still make changes to make the best plan. What I heard someone talk about at the local, there's an organization that anybody can come to. It's called PASS, P-A-S-S, Professional Association for SQL Server, and they have great seminars every month. It's free. And so anyways, what someone recently said at one of those meetings was, it's like trying to assume that you're smarter than the optimizer, which sometimes is the case, but usually the optimizer is pretty smart and it's able to change.
So do we have, like in Oracle, we have rule-based optimizer and cost-based optimizer? Do we have anything in SQL Server?
I'm sorry, I didn't hear you. What type of
In
optimizer?
Oracle, we have a rule-based optimizer and cost-based optimizer. Do we have in SQL Server kind of? Or SQL Server interns decide what optimizer to use?
I'm only familiar with just the optimizer. I guess that maybe at a low level, but it's not something that I've ever had to work with other than just the optimizer.
Because in Oracle, you have a rule-based and a cost-based.
Okay.
I'm not sure what SQL Server.
Yeah, I've only ever heard it referred to as the optimizer, so that's possible. I really haven't ever worked with Oracle, so yeah, I couldn't answer that question. Go ahead.
So sometimes it's better to have the field in the include in the index rather than as a field, rather than as an index field. But there's just some counterintuitive.
I think what's happening is the first query is looking at employee manager ID equals 109. So when it does that initial scan or seek, it needs that employee ID, but it doesn't care what the contact ID actually is. And so it has to scan the whole table because you're looking on one piece of data where it's expecting two.
Right, you're not really searching on the contact ID in this instance. You're searching on the manager ID. Whereas if you were going to look at the contact table, then you would need the contact date. So it's including that contact as a subset of information. So it's saying, here's all the manager IDs in 109, and here's all the contacts underneath them as a subset, so that it can make that query go faster. So correct, it's a matter of, because it's not actually searching on the employee's contact ID, it's only searching on the manager ID.
Okay.
I think if I was to add and employed contact ID equals whatever, then we would see a very different situation.
Okay. So it's really being driven by the where clause rather than the when.
Right.
Okay.
All right. By the way, how long does this particular session go? No.
As long as you want.
As long as I want. All right, 10 minutes. All right, I'll hurry up a little bit. Query number 5. Okay, let's run it and see what happens. Oh, I got to switch databases for this one. All right, so first thing I want to show you is there's a little plus symbol down here. I'll see if I can zoom in on it for you. Whoa, it really zoomed in. All right, so there, the little plus symbol. That's nice. It's useful to use when you have a big plan that you look at. Lets you move around the screen. Click and hold and just drag. So again, I'm seeing, we got a 42 right here. We've got some 5s, a 13, a 3. So my first inclination as a DBA or someone working with this query would be to look at this 42%. I also see this as a scan. We have a seek, scan, scan. We have a key lookup. I'll talk about that in a second. But just know that a key lookup is bad. You don't want them if you can avoid them. So let's take a look at the query again for a second. See if we can make this. We can see both. So this is on the sales order detail page. So is that right there? Sales order detail and detail ID. So if you take a look, sales order detail. So right here, okay, so it's on sales order ID, sorry, sales order ID. So this is where I would want to take a look. So my first inclination is to drop the index here, sales order ID, and this is customer ID. Let's see, why is that? Customer ID, it's coming from there. So let's see, go ahead and add that, including some data that was in the select. All right. Again, I'd be showing you normally all of the percentages. Didn't seem to make a big difference. Maybe there's something else that's not going right. So let's take a look at customer next. So look at sales order detail. Just to go faster, I'm just going to go right to the index. So I decided to drop the index and let's just do it on sales order ID, see if that makes a difference. Okay. We run this query. Still doing a scan. We're still doing a bunch of scans, it looks like. All right, let's go down. Another one. Oh, this one's on customer. Thinking maybe customer. Kind of typically walk through this in this presentation. Maybe the customer's causing the problem. So let's work on customer now. Customer. So now I'm adding an index on customer ID on the customer table. Still not helping us. So what the problem is, and usually I try to have people interact and tell me what the problem is, but again, in the interest of time, the problem here is that there's no where clause. So no matter what I do, it's always going to have to do a full scan on sales order header and come back with every single record for sales order header. So no matter what I'm doing index-wise, without having that where clause, it's not going to matter. It's going to be full scan on the table. So by adding that where clause, if I add it right here, I run it. Now we're going to start to see seek show up. So no matter what you do, this is where you have to look at your query too and not just look at the plan and see what's really going on.
Would you typically use the client statistics to compare your performance after you add an index?
Yeah, so I could do a set statistics on the top of this, and we can talk about that. There's also, you can go to query, where is it? There's a button here for it. Query options, and you can set your statistics here. Yeah, and that depends on what you're looking for too. I mean, if I'm really interested in getting that information about time taken and the other information that comes back with that, then yeah, I can do that.
I guess I'm a little confused about
Sure.
like how that where clause affects all the other ones, because I would think like it would affect one, but not all the others. Because when we get to the nested join,
Right.
like essentially you need all the data from all the tables no matter what, except for the sales, wherever SOH came from, the sales order header table.
Yep.
So that's the only one that gets limited. All the other ones, you still need all the data from all the tables to do the join.
You need all the data that matches to the data from sales order header, right?
Right.
So if sales order header only has one bit of data coming back, you'll need that one customer ID, assuming that's a one-to-one match. But in this case, you need every single customer associated with every single sales order header.
Sales order header is the driving table here.
I'm sorry, I just didn't.
Sales order header is the driving table.
Right,
That's
sales order
right.
header is the driving table.
So if we looked at the execution for sales order detail, would that ID be in that the sales order ID be specified in the plan?
Take a look at it. Sales order detail. Header. Store. Here's sales order detail. All right, so here's sales order detail without the where clause. So that's what you're saying, right? Or did you want it with the where clause?
Well, that's one. Okay, so I've seen it before. It doesn't specify any index here.
It specifies sales order detail I01.
Okay.
But I believe that the relationship between sales order detail and sales order header is the one-to-one. So it basically needs every single sales order detail because it's getting every sales order header.
Can you add the where clause and execute it one more time?
Sure.
Go back.
Sure. Alright, product, sales order detail. Still using sales order header detail ID, but it's because it doesn't have to do a full table scan because it's not getting every single record back, it can use that index efficiently, which is why it's coming back as a
Yes, I know it's using the seek criteria.
Right, because it was a one-to-one before, it had to get every single record from that table, because it had to get every single record from its base table, because there's a one-to-one on it.
Yeah.
In this case, because that's not the case, it's able to just go right down to just the ones that it needs.
Thank you.
Yep.
There's a question about, so the scan basically implies that all the records in that table are going to be hit, and seek implies that all the department records are going to be hit. That
Seek says it's using an index to go right to the area that it needs. So again, if I wasn't clear this before, think of it like a phone book. So a scan is you have to go through every single page, look at every single entry, trying to decide, is this one that I need or not? Seek is, I want the Johnson mark. And so I go to J's, and I go right down to JOH, and that's how the index works. So I can skip all that stuff before then. I know it's not going to be before or after because the index tells me this is the range where you're going to find that data. Does that make sense?
so there's no such thing partial scan of the table.
Yeah, no. Because
you couldn't have a seek that grabs 10 of the 1,000 records in the table, and then it does a scan of those 10.
imagine like in our first example, our second example, where we were searching on manager ID, but there was no index on manager ID. So if it was to do a partial scan, those manager IDs could be 1, 1,000, 3, 50, 105. So they're not in any order. So doing a partial scan, it'd be meaningless because you wouldn't necessarily know that you got all the data back.
I guess I was thinking the other way. If you do the seek, returns 10 records from the seek, and then do the scan, and then the results that come from
You could see that. So what you're saying is, I put manager ID in, but there was a join on something else. So it got those managers, and then based on those managers, it did a scan for the whole deal. Yes, and it definitely could do that.
So that would just help the tree and the execution.
Right. But because we saw before that it was using the index even when it was a scan, so it still had to get everything. So once we went to just having specific ones that we needed, it was able to then use that index efficiently and go right to the spot that it needed. I think thinking about time, I'm going to skip the last one. I just want to talk just briefly for a second about text plans and XML plans, and we can be done. So, text plans. Down the list. All right, here's text plans here. So again, if you want to see more of this, or if you want to see the full set, just go to the blog. I'll put that up in a second. So to do a text plan, they also have estimated and actual. So if I was to run this whole thing, it would give me an error. The page wants to be the only thing that runs during this batch. That's because it's an estimated. It doesn't actually want to run the query. So I'm going to go ahead and turn it on. run it. And I'm not going to show you the actual because it looks pretty much just like this. So this is what a text plan looks like. As you can see, you have some more data. It's laid out differently.
Are there better visualizers that you would take these text plans and import them into?
There may be. There's some third-party products that you can use to give you better information. I think there's even I may even have one installed. Yeah, SQL Century Plan Explorer. Kind of a weird tool. Yeah, I just because of time, I don't want to get into it. We can look at it afterwards. So this is an XML. Now, SQL Server 2005 and above, I want to say, made a change. And if it's well-formed XML, it's able to kind of display it. So this is the XML. Here's the code for it. But if I click on it to see it, it's actually going to take it and display it for me. So if I actually want to see the XML, what I have to do is I have to right-click on this and then go to Show Execution Plan XML. And then there's the XML. As you can see, we got a lot more data than we had before. Now this can be very useful. This can show you information like parameter sniffing. So if you passed a parameter into a stored procedure and the query optimizer had based its plan around a different value, and because of the way the values are and the way that things are laid out, it creates a different plan, which can happen. I don't want to get into that because we're basically out of time, but you can find that information out by looking at this. What plan it was using, or what value it was using in the plan, and what value was sent in. So that's the way for looking at information like that. So this does have use. It's just a lot more data to look at. Any other last-minute questions? Otherwise, we can talk afterwards. All right, thank you.